Welcome to our previous year question series designed chapter and topic wise that will help you improve your score in your board exams. Question 1. According to Coulomb's law, which is the correct relation for that following figure? And it is a question from CBSE sample question paper 2022-23. So a figure is given to us, and in this we are having two charges, Q1 and Q2. The force on Q1 due to Q2, it is towards Q2, that is F12, and the force on Q2 due to Q1, it is towards Q1. So it means this thing that the force between Q1 and Q2 is attractive in nature. And this is possible only when these two charges are having opposite signs. So if Q1 is positive, then Q2 has to be negative, and vice versa. If Q2 is positive, then Q1 has to be negative. Now we need to select out the correct relation. Relation 1, it says Q1 multiplied by Q2, it is greater than 0. Since the two charges are having opposite signs, their product cannot be greater than 0. So option 1 is incorrect. Option 3, Q1 multiplied by Q2 is equal to 0. No, it is not equal to 0 because they are having some magnitude as well as the sign. So their product is not 0. Option 2, it says Q1, Q2 is less than 0. And when one of the charge is positive and other is negative, their product is negative. So positive multiplied by negative will always give us negative value. So from this, we can conclude that option 2 is correct. And this is the answer for this question. Question 2. 2-point charges placed in a medium of dielectric constant 5 are at a distance r between them. They experience a force capital F. What will be the electrostatic force between them in vacuum at the same distance? So we are having two charges, Q1 and Q2, and they are separated by a distance r, and they are placed in some medium that has dielectric constant 5. So let F be the force between them. So F can be written as 1 upon 4 pi epsilon, where epsilon is the permittivity of this medium, Q1, Q2 upon R square. And we know that there is a relation between epsilon and epsilon naught. That is epsilon upon epsilon naught, it is equal to K, that is dielectric constant. Or in other words, I can write epsilon as K times epsilon naught. This K, it is also known as relative permittivity, that is epsilon r. Now let's take these charges and place them in vacuum at the same distance r. Now the force F dash between them, it can be calculated as 1 upon 4 pi epsilon naught Q1 Q2 upon R square. And from this, I can write that epsilon naught, it is equal to epsilon upon K. And in the question, K is 5. So in place of this epsilon naught, I can write epsilon upon 5. So F dash, it becomes equal to 1 upon 4 pi epsilon upon 5 Q1 Q2 upon R square. And this 5 will go in the numerator. This will give us F dash is equal to 5 upon 4 pi epsilon Q1 Q2 upon R square. And this value that I'm encircling, Q1 Q2 upon R square divided by 4 pi epsilon, it is equal to F. So this implies this thing, that F dash, it is equal to 5 times F. So when we have taken the charges in vacuum, then the force between them has increased 5 times. And from the given options, option A is correct. Question 3. Two charges Q1 and Q2 are placed at the centers of two spherical conducting shells of radius R1 and R2 respectively. The shells are arranged such that their center are d distance apart, and this d, it is greater than r1 plus r2. We need to find the force on q2 due to q1, neglecting the induction effects. And it was asked in 2023 CBSE question paper. So let's try to visualize the scenario that is given to us. So this is shell 1, and at the center of shell 1 we are having q1, and this is shell 2 of radius r2, and at the center of shell 2 we are having q2, and q1 and q2, they are at a distance d. So the distance between the centers, it is d. Now we need to find out the force on q2. So since this q2, it is at a distance d from q1, we can write F is equal to k q1 q2 upon d square using Coulomb's law. And this k, it can be written as 1 upon 4 pi epsilon naught. So we can write it as 1 upon 4 pi epsilon naught q1 q2 upon d square. And in the question it is given that we can neglect the induction effects. Otherwise, this q1, what it would have done? It have created minus q1 here, and the same charge plus q1 is distributed on the outer boundary. Similarly, it will create minus q2 here, and plus q2 is distributed on the outer boundary. And the effect of all these four charges on this q2, it will be in such a way that their combined effect will be 0. So the total force acting on q2, it will be k q1 q2 upon d square only. So hence option A is correct. Question 4. Three identical charges of plus q charge each are placed at points A, B and C such that AB is equal to BC is equal to D. So we are having three charges plus Q and plus Q, and they are placed such that AB is equal to D and BC, it is also equal to D. We need to take A as origin. So A is our origin, and we need to find the force acting on the charges A and C respectively, and it is given to us that the force between A and B is F. So we can say that force between AB, that is equal to K Q square upon D square. K Q1 Q2 upon D square, but here Q1 it is equal to Q and Q2 it is equal to Q. Both on multiplication will give us Q square. So this is the force between A and B, and its magnitude is F. It is given in the question. Now we need to find the force on charge A and C respectively. So force on charge A, it is because of two charges. One is the charge placed at B and the other one is the charge placed at C. So we can write it as force on A due to charge placed at B, that is FAB, plus force on A due to charge placed at C. And this is a positive charge. So this B, it is also having a positive charge. So the charge on B will try to repel it towards the negative x-axis. Similarly, the charge on C, it is also positive, and it will try to repel the charge present at A towards the negative x-axis. So this is my FAB, and this is FAC. Now I can solve it out. So FAB, it can be written as K Q1 Q2, and here Q1 and Q2 both are Q. So we can write Q square divided by the distance between A and B, that is D square, and it is towards the negative x-axis. So I will write minus I cap plus FAC. So FAC, it is equal to K Q1 Q2, again Q square, divided by 2D whole square. And this 2D whole square, it is because the distance between A and C is 2D. And also the force FAC, it is towards the negative x-axis. So I'll write minus I cap. So on solving it, I can write minus kq square upon d square minus kq square upon 4d square, and it is taking this minus common. I have taken I cap over here. Now I can further solve it out as kq square upon d square is f. It is given to us. So I can replace this complete value with f. So it is minus f minus of f upon 4 with a I cap. So when I solve it out, it will be minus 4f minus f divided by 4 I cap, and that is equal to minus 5f upon 4 I cap. So this is the value of force on A due to other two charges. We also need to find out the force on C. So Fc, it is the force on charge placed at C due to charge placed at B and charge placed at A. So it will be F BC, that is force on C due to charge placed at B. It will be towards the positive x-axis because this is a positive charge and this is also a positive charge. The charge on B will try to repel it. So this will be F BC. Similarly, the charge on A, it is also positive. It will try to repel the charge present at C towards the positive x-axis. So this is F AC. Force on charge present at C due to charge present at A. So that will be FAC. Again, I can solve it out as K Q square upon D square and towards the positive x-axis. That's why I can. Plus K Q square upon 2D whole square again towards the positive x-axis. So multiply it with I cap. And it is already given to us kq square upon d square is f. So it will be f I cap plus f upon 4 I cap. And when I solve it out, it will be 5 f upon 4 I cap. So this is the force on the charge present at A, and this is the force on the charge present at C. So from the given options, I can say that there's 5f upon 4 I cap and minus 5f upon 4 I cap. Option A is the, sorry, not option A is correct. Option A is not correct. Option C is correct. Why so? Because it is minus 5f upon 4 I cap, that is the force on A, and 5f upon 4 I cap, that is the force on the charge present at C. So option C is correct. Although magnitude wise A is correct, but we need to take the sign into account as well. So option C is the correct answer. Question 5. Define dielectric constant of a medium. What is its SI unit? And it has been asked in 2015 in CBSE board exam. So dielectric constant is the ratio of permittivity of medium to the permittivity of vacuum. So mathematically, it is epsilon upon epsilon naught, and that is equal to K. It is also known as relative permittivity. It tells us this thing that how many times the permittivity of vacuum is the permittivity of the medium. So if we need to find out epsilon, I need to multiply epsilon naught with K. So K is that value which will tell us this thing that if I multiply epsilon naught with that value, I'll get the permittivity of the medium. And since it is the ratio of similar quantities, it has no unit. In other words, it is unitless. It is just a constant that has no unit. And that's the answer for this question. Question 6. Two equal balls having equal positive charge q coulombs are suspended by two insulating strings of equal length. What would be the effect on the force when a plastic sheet is inserted between the two? So let us take the two balls, and each of these balls, they are having a charge q, and let us take that they are separated by a distance d. So the force between them, it can be written as 1 upon 4 pi epsilon naught q square upon d square using the Coulomb's law. Now I have inserted the plastic sheet in between. So this is the plastic sheet that is inserted in between, and the distance between the two balls, it remains same. Now what has changed? The permittivity of the medium has changed. So f dash, it will be equal to 1 upon 4 pi epsilon q square upon d square, where epsilon is permittivity of the plastic sheet. Now, this epsilon, it can be written as k times epsilon naught, where k is the dielectric constant of the plastic sheet. So I can replace this epsilon with a k times epsilon naught. So f dash, it is equal to 1 upon 4 pi k times epsilon naught q square upon d square. And if I rearrange it, I can write it as f dash is equal to f upon k, because every other thing, that is 1 upon 4 pi epsilon naught q square divided by d square, that is equal to f. So in other words, I have got this thing that f dash has become 1 upon k times f. So the force between the charged balls is decreased by 3 units. So when we insert a plastic sheet, the force between them, it decreases. And by how much? By k units. And this is the answer for this question. Here k is the dielectric constant of the medium that is inserted between the balls. Thank you. Keep learning, keep practicing, keep excelling.